Long time no see, I'm Hein. This semester I'm planning to reviewing the nanoelectronics, but before we start the reviewing the nanoelectronics, I'm going to review the last subject like fundamentals of the semiconductor devices or fabrication of semiconductor devices. Today I'm reviewing the fundamental of semiconductor devices. As we talked a lot about the basic concept of the molecules. Today I'll skip this and I'll start with the what is the semiconductor. As you can see in this screen, this is insulator, semiconductor, and metal. The semiconductor is the material which has the middle band gap. Insulator is the material which is have the very big band gap, so the electrons can't move to the conduction band from valence band, so it can't flow the current. In opposite, the matter is the material which have the very small band gap or there's no band gap, so the current flows very well. But in semiconductors, the carriers can go up to the valence band, go up from the valence band to the conduction band in according to the environment. So we call these materials as semiconductor materials. Usually we use the semiconductor materials with the silicon in semiconductor industries. When we adopt the 5 or 3 families in the semiconductor materials, we can make a adopted semiconductor. When we contact the p-type semiconductor or n-type semiconductor together, we can make a diode. Diode is the device which make the current flows in one directions. This is the energy band of the diode. Because the Fermi level, because the Fermi level of the semiconductor is constant in the equilibrium state. So when we contact these two types of semiconductors closely, because the Fermi level is constant, we can make the energy barrier like this. Because of this barrier, the electrons in the one side can move to the other side. So it acts like a insulator. But when we apply a bias, the forward bias in this, the energy band of the higher positions goes down, so the energy barrier become lower than ever, so the electrons can more easily move to the other side. With this principle, we can make a diode which can filter the direction of the current. And next, I'm gonna tell you about the MOSFET. MOSFET is the structure which have the 3 materials like M, metal, O, oxide, and S, the substrate, which is silicon, and it forms the capacitors, metal and silicon, and go in the middle, the oxide becomes the insulator. So in most caps, we can control the current which flows in the surface of the junction between the substrate and the oxide by controlling the bias in gate, which is called metal. So this is the basic concept of the MOSFET. But when we injection some dopant in the MOSFET, we can make a MOSFET. MOSFET is the field effect transistor. So we can make like these structures like this. So when we apply some gate bias on the plus bias on the gate in the N-type substrate, P-type substrate, we can make a channel like this. Because of the positive bias pulls the electrons in the substrate, so we can make a channel like this. And in this situation, there is only channel, and if you want to make a current, we have to apply the drain bias. Applying the drain bias means to make a slope in the energy band. When we apply a gate bias, only gate bias, the energy barrier becomes a little bit lower, like this. The black line is higher and the red line is the lower energy barrier, but there's no slope, so the electrons in here can move here, but it can't to this side. But we apply the drain bias, the positive bias in the drain, the energy band goes slow down, so when the electron moves to this side, it can move here because of the drift of the current. So like this, today I briefly reviewed about the semiconductor and the diode and MOSFET and MOSFET. Maybe next week I will talk about some more about this. Thank you for listening.